today I'm going to be talking about something that I've been working on for maybe the last 6 or 8 months. And I released this project kind of as a proof of concept in November to kind of demonstrate some ideas all put together into this big system of integrated things that kind of, or in what my opinion is going to look like the future of kind of where a lot of the tooling and things that we're working with now. So it's kind of like a combination of everything from serverless to Jamstack, static sites, to React, and a lot of the different plugins and things that I've used for this project are probably things that you've probably used also, and maybe some of your projects, or maybe they're things that you've maybe heard about. And I think the most interesting thing about the project that I'm going to be talking about is kind of not each individual piece, but how everything kind of fits together and how we kind of made this thing work, or how I kind of made this thing work. And a lot of people, I would say, kind of helped me because I had to reach out and ask questions and get feedback and ideas around how to solve certain problems. So yeah, so the name of the talk is Building a Full Stack CMS for the Modern Age. My name is Nader Dabit, and you may have seen me on Twitter at Dabit3. This is my avatar. This is kind of how a lot of people know me, and I think I look like that right now, except I have my glasses on, so that's always good. And that's my son, Victor. So the team that I work on at AWS, I am a front-end developer. When people think of AWS, they typically don't think of front-end developers. They think of cloud, and they think of infrastructure, and they think of DevOps and back-ends. Well, my team is a client technology team. Everything that we work on is built for full-stack development, and we have a ton of front-end engineers, including myself, that are on the team. The two main things that I work on and I work with are AWS Amplify and AWS AppSync, and these are kind of two parts of what build or make up the things that I'm going to be talking about, but they don't have to. The ideas that I'm kind of talking about and the tools and the things that I've open sourced recently are actually what I'm really trying to do is make them back-end agnostic. So you don't have to use AWS. You could use Azure. You could use Netlify. You can use anything that you'd want. You can actually build your own back-end. The reason I used some of the tooling that I'm using here, besides the fact that I work there, is because I know this stuff really well, and it made it easier to kind of build this because it is what I know. But I think really, if you kind of look at what the things I'm going to talk about are, you might be able to plug in your own expertise and kind of take the ideas and do stuff yourself. Amplify, by the way, is a full stack cloud framework for building mobile and web applications, and then AppSync is a managed GraphQL service. And I've done, I've written a couple of books, React Native in Action, and then Full Stack Serverless. I've done podcasts and other stuff, but the main thing I'm really kind of excited about right now is this book, Full Stack Serverless. And this book is really about what I'm about to talk about, putting all this stuff together, building full stack serverless, full stack cloud applications, using GraphQL, using React, and using cloud technologies. And kind of what all of the things that we're working on in my team and all of the things that I've used to kind of build this system are really revolved around these core concepts or strategies. Developer velocity. So I think that one of the most important things as a developer, if you're going to be experimenting and being able to kind of try out new ideas, is having the ability to build something quickly and tear it down quickly. So developer velocity is something that I really value, and whenever I see something that adds a lot of, or enables a lot of developer velocity, I tend to kind of gravitate towards that. And a lot of these things kind of like go together. But when you think of developer velocity, think of what happened when DHH released Ruby on Rails. And think about how popular that got. And I think one of the main reasons that it became that popular is because it enabled developers to get up and running quickly with a certain group of functionality that they had been writing over and over, rewriting by themselves from scratch. But Rails kind of enabled you to kind of scaffold all this stuff out, and then you can take it and configure it from there. Scalability, so cloud enables scalability typically by default, especially serverless, because you typically don't have to worry about scaling your infrastructure. Scalability is kind of built into the serverless manifesto, or you could say philosophy. Developer efficiency, I would say, kind of goes along with developer velocity. Performance, so making your app fast. A few things kind of go into this, but we'll talk more about that in just a moment. And then experimentation is very valuable, especially in the age where people are iterating and building and competing, and you're competing against the entire world pretty much, right? When you open a company, you're no longer competing against the people that are next door to you, because someone across the globe can come up with the same idea as you and build it. And they can build it better, maybe better than you. So being able to experiment and create new features without costing a lot of time and money is very important, right? Because to compete and to stay ahead of everyone, you need to be able to try new things and test them out, find out what works without a lot of overhead. So I guess with that being said, let's take a look at what the core of what I built is kind of going to model. And what I'm going to look at right now is WordPress. Now, WordPress is something that we've probably all used, and maybe we've even built stuff with it. For me, it's what got me into programming. I learned PHP and I learned WordPress early on. But WordPress is just a magnificent success story, right? It's extremely widely used. It's very popular still. It's a full stack content management system. It allows you to build, web pages, but also blog posts, e-commerce sites, all these things. And you don't really actually have to know how to code to use WordPress, because when I started using it, I didn't know how to code at all. I was able to deploy WordPress and use the CMS part to kind of create a website, and I thought I was a developer, and I was a developer. I may not have been an engineer or something like that, but I was building websites. I was developing websites. WordPress 68 or 61.8 CMS market share as of 2019, at least based on the data that I was able to find. Powers 35% of the internet, available in over 100 languages. Anyway, all these stats are just, massive when you think of the number of sites that are built using it. So why did WordPress get this popular? Well, think about what you get out of the box with WordPress. Think about what you get out of the box with something else like Rails that also became wildly popular. You get a lot of stuff, and you get it without having to do a lot of work. You get client and server-side code. So with WordPress, you get the JavaScript, the PHP. Now, this is like extremely important part of it, in my opinion, because if you've ever built this, and you probably have, the first time you start diving into authentication and authorization, to me, it's kind of one of the hardest things of becoming a developer, is understanding everything that goes around that, all the encryption, all of the authorization, managing users, dealing with all of the edge cases. Like I mentioned earlier, it's essentially codeless. Yes, you do need to write your own code if you want to kind of really customize something, but you don't have to. It's themable. The database configuration is included. This is another big part of it. When you deploy a WordPress installation, all you have to do is configure a MySQL table to kind of connect with the installation itself, and you don't actually have to write any of the code talking to the database. It's easy to deploy to a bunch of providers. So with WordPress, you can kind of just go into a host and click Add WordPress, and it's there. And it's just a great CMS. So why would we want to make this better? And that's kind of what I've attempted to do, or kind of the proof of concept that I've kind of built is hoping to do. Well, to understand what we can improve, let's look at the drawbacks that are associated with WordPress, in my opinion. So performance, first of all, in my opinion, is a huge difference between a lot of the single-page apps and the Jamstack apps that we're building today. When you go to a WordPress site, it sometimes takes seconds to load, like 5-10 seconds. When you even navigate from page to page, it's server rendered, and it's loading a bunch of stuff, and it takes a lot of time. Security, WordPress is like one of the, I think, the #1 target of hacks that have to do with actual public websites for a bunch of reasons, but one of the main reasons is just because there's so many sites out there. It makes it a good target, because if you learn how to hack WordPress, you can hack a bunch of different WordPress sites. So even though WordPress is typically known as being SEO friendly, it's not as SEO friendly as a handwritten site or a statically rendered site. Code bloat, when you're working with WordPress, you have a lot of code, and if you're new to WordPress, you probably don't know what's going on. And then you start adding themes, and you end up with a ton of code. And then PHP. Who wants to write PHP? No, I'm just joking. PHP is great. But I like writing JavaScript. So now let's take a step back and look at philosophy around some of the kind of things that are happening in the industry today. One of the things that you're kind of seeing are serverless technologies. And one of the things that I'm excited about, and one of the things that, like, I see people in the industry doing in their own form or fashion, is full stack serverless, which is basically the combination of front end and back end using modern technology and, like, I would say serverless technology. So really what this comes down to in the example that I've built and the examples that I'm kind of working with are a combination of infrastructure as code and client code. So the infrastructure of code as code is the back end, and the client code is the front end. The client code could be anything, though. It could be web, mobile, desktop. It doesn't really matter. And then the back end code could deploy your preset infrastructure into whatever cloud provider that you would like, because being able to write your infrastructure as code is pretty powerful and interesting, and we'll take a look at that right now. So let's take a look at what infrastructure as code is. Well, infrastructure as code is exactly what it sounds like. It's code that you write that deploys infrastructure. Now, as a front-end developer like myself, this was really a big rabbit hole when I started looking at it, because it's super powerful, but it's really complex, because you have to understand not only all of the different ways that you write this infrastructure as code, but you have to understand everything that goes into it. So if you can't just say, oh, I want a database, because you have to know all of the syntax and things that go along with that database. But essentially, you write some configuration, you write some code, you then deploy this into some cloud provider, and then you get resources. You get a database, you get an authentication service, you get an API, you get whatever. So let's take a look at the different ways that you can do this and how we are seeing improvements, I guess, in this industry a little bit. First of all, the most basic form that you see a lot really in all the different cloud providers is configuration-based. Configuration-based is typically written in JSON or YAML, and you'll see things like CloudFormation, Terraform, and Serverless Framework. Those are three of the most popular ones, but there are actually dozens and dozens of them out there. Things like Apex and a lot of other stuff. A lot of those are actually built on top of CloudFormation, but CloudFormation is only for AWS, so Terraform works across all the different cloud providers. So you can do Google, Windows, or Azure, I'm sorry, and AWS. And then Serverless Framework is really great because it's kind of a higher level abstraction on top of these other ones. So Serverless Framework is kind of a little less code, and you can do most things that you would need to do. So those are kind of like the config-based. What we've seen come lately is the code-based, actual code. So infrastructure is code, and the config base is typically JSON or YAML, whereas the code base is actual code. So you can write TypeScript or Python or whatever language that you like. And I think CDK is the first big one that I know of that actually did this. And I'm sure there's others out there, but the idea here is that you kind of write TypeScript or, like I said, Python or whatever, and then you deploy your infrastructure using your actual programming language of choice. Something that we've been working on, though, on my team is CLI-based infrastructure as code, because, again, we're not targeting back-end and cloud engineers. We are working with front-end developers that don't know and don't want, and we don't think they need to know all of this stuff that goes into these configuration files. Like when you look at CloudFormation files, it's not unlikely that you'll see 2,000 to 20,000 lines of code. And when you start going through that, you start noticing a lot of repetition, a lot of boilerplate. So we think that there's like better ways, in my opinion, to kind of do this. So what we've built, and I think you're going to see more things out there like this, are a CLI-based approach that goes along with these ideas of categories. So instead of saying, I need this type of database with all of this configuration, and I need to know all of this syntax that goes along with it, we can just say, I want a database, or I want storage, or I want authentication. We then walk you through a bunch of steps that will then ask you questions. So you say, I want an API. Okay, do you want a GraphQL API or you want a REST API? Oh, I want a REST API. Okay, do you want this, or this? And then you kind of like go through, and as you answer these questions, we're writing that CloudFormation under the hood for you. And you don't actually have to touch that CloudFormation or that config-based infrastructure as code. It's kind of all handled for you by the CLI. So you can then run commands like checking what is going on in your environment. So in the CLI itself, you'll see information about your project, and you're never touching that infrastructure as code. When you're ready to deploy, you don't actually, again, have to go into the cloud yourself. You just run a command line command. So you say push. This will take that CloudFormation, take any JavaScript or GraphQL that you have in your local project that you would like to deploy. It will bundle all that up and then deploy that. So, like using these ideas that I've talked about, let's think about how we could take on a company like Automatic. Automatic is, they have WordPress, but they also have things like WooCommerce and all these other companies worth about $3 billion. Whenever I pulled this stat, I guess the end of 2019. And the idea is we want to kind of say, okay, this is 2020. We think that Automatic is working on 2010 software and ideas. How can we, as a startup, build something and kind of take over and kind of be that unicorn or kind of create something that, you know, takes their idea but makes it 10x better, right? That's kind of the idea when you have a startup. You want to make it at least 10x better. That way you can gain market share. So to do that, we have to define the requirements. For me, this is a short list of what that looks like. Client-side code and server-side code all bundled together, again, for that full-stack CMS. We want a database and a database configuration. We want to have authentication and authorization built in and allow admin access as well as just typical user access. And we want to be able to easily deploy this entire stack, just like WordPress does. We want to kind of do this as well. So that means this kind of needs to be an all-in-one comprehensive thing. We also want to make some improvements because I noted all the things that are lacking with WordPress. Let's look at how we can address those. Well, we want to make it cheaper. With WordPress, you are actually serving a request every time you hit a page. A way we can make this better is by using statically rendered site and kind of serving just a statically rendered site from a cache somewhere in a CDN. We also want to make it faster. Again, with a statically rendered page, it's going to be faster because we're not actually requesting anything from a database, we're just requesting HTML. We want a better developer experience. We want to be able to write JavaScript and not PHP. We want a modern tech stack. And we kind of all want this to be kind of built in together into this system. So what is the stack going to look like? The stack that I chose is this, Gatsby for the client, for the entire like framework, I guess you could say, which is built with React. Gatsby is a way to kind of build static sites, and if you're in this meetup, you've probably heard of it and you've probably used it. There's also really other good options that would work just as good, in my opinion. Next.js and Nux are both, falling into this similar category. For the database, I chose a NoSQL database that is an AWS database, DynamoDB. We have a really massive scale customers using it, so I know it works really well. And it is built into some of the tooling that I'm working with already. And you'll look and see how that works in just a moment. For the API layer, I chose GraphQL for a couple of reasons. First of all, we're going to look at how, when you're modeling your GraphQL schema and how you can evolve this schema, how that GraphQL kind of brings a lot to the table in that sense. And I think that's kind of the main reason, is because I wanted to make this configurable. And the easiest way to do that is to kind of have your GraphQL schema defined in one place. People can go in and kind of make changes and then deploy their version of your app. And it's really easy to do that when you're working with GraphQL types and GraphQL fields. So you also need image and video storage. You could use something like Cloudinary. You could use something like whatever service you want to use. I use S3. It works good with the framework that I'm kind of building again. And then an authentication service, Auth0, some type of managed authentication service needs to be able to be deployed because you don't want to actually have to kind of like, I guess you could maybe even replace Cognito with your own full stack, I guess, authentication service, but you would have to write it from scratch. This is kind of like a managed authentication service, similar to Auth0, that works pretty good. And now we're going to look at putting it all together. On a scale of 1 to 10, what do you think about the animations? Because I've never really done animations until now, so I'm just kind of curious. Any feedback? Okay. If you hate them, let me know. Anyway, so we're going to kind of take this step by step. Let's look at each piece that we need to build this. First of all, we want an API and a data source, and we want this kind of to be tied together. The considerations, in my opinion, that were most important were easy to modify. We wanted to have public and private access. So for a blog and a web page, think of Medium. You need to be able to have serve all of your pages either publicly or privately. So if I create a page and I want to edit it, and I don't want anyone seeing it until I publish it, that would be private access. Public access means that you've published it publicly. And then I guess Medium has this new like special access where if you view it 3 times, they put a big blocker. I don't know what I would call that. Maybe hater access. And then API gateway and database. So we need to have an API endpoint and a database that kind of connects all this stuff together. So how did we build this to make this all configurable? So again, let's take a look at the schema that I'm working with. So I use GraphQL, and this is kind of all the schema that I used. I have a post. This is a post, for a blog post. I have a preview because I want to enable people to, while they're writing a blog post, be able to share the link without it being public. So we can generate a dynamic preview link that is a very random URL, and then you can share it with your friends. We also have a page. So think about WordPress. You can create posts, but you can also create pages. I wanted to enable people to go into the admin panel, create a blog post, but they can also create an actual web page. We needed a user to keep up with a user that is working within the system. And then we wanted to enable comments as well. So if someone decided you can flip this on and off. If you want to enable comments, you can. If you want to disable them, you don't have to use them. Now, this is a very basic thing. How can we put all these other things that we need? So you have the schema, but what about things like associations? We want to associate a comment with a post. We want to associate a user with a post. We want to associate a user with a page, right? So, we kind of need to have all these associations. We also need that database, and we need to tie it all together. So something that we've built that is kind of specially made to kind of allow all of these things to kind of work together is this GraphQL transform library. GraphQL transform is a set of like 8 or 9 GraphQL directives. The 3 that I use for my app are @model, @auth, and @connection. So @model is the first one I'll talk about. @model basically allows you to decorate any GraphQL type, and we will then automatically generate 3 main pieces. First of all, we'll generate a database for that type, for the type. So for instance, we have a post type. We decorate it with @model. We generate a DynamoDB NoSQL database. We also need schema for that type. So for instance, a post, what actions do you need for a post? You probably want to create, read, update, delete, and list posts. So we automatically generate all the schema, and then we also generate the resolvers that talk between the database and the schema. So with that out of the way, we also need to define authorization rules and authentication, which kind of goes along with this. So to do that, we can use the @auth directive, and we'll look a little bit more in that in just a moment. And then finally, to define relationships between types, we can use @connection. This way we can do one-to-many, many-to-many relationships. So now what we're going to do is we're going to take this post type, and we're going to start decorating it with these directives. First, we need a database, and we need CRUD, and we need resolvers, CRUD schema resolvers. So we add the @model. We then need to add authorization rules. So the 3 types of access that I want to happen is, first of all, I want to allow an admin that is anyone to be able to go in and make whatever updates they want. They can create, they can read, update, delete, they can do everything. We also want to make it so that if you're an admin, you can actually go in and kind of do stuff. We also want to make it to where if you share a link, that person can only read the link. They can't actually update or delete it. So we added a private field or a private rule, and then the only operations we allow are read. And then we also need to have one more rule, because when you're working with Gatsby, you typically have two types of data, or two types of data that you're reading, I guess you could say. One is static at build time, and one is going to be dynamic at runtime. For build time, we need to kind of say, hey, we want to go to our API and we want to get this data. So we need like an API key type of access. To do that, I set public. This will automatically generate an API key, and then we can use that API key to read the data at build time. And then finally, we need to have, yeah, we already went through all those. Finally, we need to have a way to model relationships between two different fields. So to associate a user with a post, we can set the user as the author, and then we can add the @connection, which will automatically generate a one-to-one relationship between the user and the post. So when we run this schema, we add these directives. What we end up getting is a GraphQL endpoint. We get the GraphQL schema, so CRUD, read, list, operations, all of that, resolvers, and then we have basically the entire infrastructure we need for the API done. Next, we need to work with the data. So now that we have the back-end part kind of deployed as far as the API layer, we're going to look at reading the data on the client. Because when we're working with Gatsby, let's take a look at how this works. You typically create a new Gatsby project, and you get something like this. And in the pages folder, you have a set of pages. So by default, you get 404 index, page 2, and maybe one other. So when you run Gatsby develop or Gatsby build, what ends up happening is in the build process or in the build phase, Gatsby takes the JavaScript that's in there and creates HTML pages and sets them in this public directory. So in the public directory, we now have 404 page 2, and we have our index page, which is just a static HTML page. So when we run Gatsby build, it'll automatically look in the pages, but how can we actually dynamically create pages in that pages directory? Because we're not using local data, we're actually using data from the API. So the way that we do that is using some of the Gatsby lifecycle methods we're just going to look at in just a moment. So during the build phase, we can actually use one of the 20 Gatsby lifecycle hooks to do this. Yeah, so I use actually 2 of them. But anyway, to work with the Gatsby lifecycle hooks, you open Gatsby node, and then in there, if you've ever worked with React, you have component did mount, component will mount used to be there, right? Component will unmount. You have all these life cycles, right? So when the React component gets created, it goes through and it hits all of these life cycles. Gatsby has the same thing on the build phases, and these are those life cycle hooks. The 2 that I worked with are create pages, and create pages allow you to dynamically create pages the way that we just looked at. Instead of actually having to hard code the data, you get data from an API, and then you dynamically create the pages in this life cycle. And then source nodes is the other lifecycle hook that allows you to also get data or get some type of data, maybe you're defining it, whatever, and then you take the data and you can actually insert this data and have it available in the entire app using GraphQL internally from any page. So for instance, and this lifecycle actually runs at the very end. So what you end up happening is, say that you have some data that you just want to have available everywhere, but you only want to kind of get that data at build time, and it needs to be available. It doesn't need to be dynamic. In source nodes, you would kind of create a method, and you would go fetch that data, and then you would and make it available. And I'm going to show you how that looks. So the 2, again, create pages and source nodes. So let's take a look at create pages. Create pages looks something like this. You have a exports.createPages created in your Gatsby node, and from there you destructure the actions, and then from actions you have this create page function that allows you to create pages. And all you need to do is fetch your data. So for me, I'm going to have a method that's called fetch posts. Pretty dumbing it down for like just a slide, but fetch posts, you could think of going to the API, fetching the posts, setting them in an array. So now we have an array of posts. What we want to do now is map over all of the posts. For every post, we want to create a page. So if I create a new post in my blog that says, hello world, I'm in Paris, I can now say at build time, I'm going to go ahead and build a page. I want to create a slug. So in the path, you can create the URL, and I have a helper called Slugify that'll just take the title and say, hello-world, I am in Paris, whatever, all lowercase. So then your website URL / that will have the post title. You then define the component that you want to use. So this is just a React component. So I have a component called post. And then you can actually also pass data and have it available as a prop. And to do that, you use the context. So here we have a context where I'm passing in the post ID, the post content, which is going to be some markdown, the post title, and then a published Boolean, because if it's not published, we do not want to actually have that build at build time. And then using that context, so we have the context of ID, content, title, published. Anywhere in any of these components that we create, we can then get this data from props.pageContext. So this way we're building the pages, we're passing the data, and then we can use that because now we have all of these pages, and then it's pretty simple at this point. So next we have source nodes, and it basically gives site and API builders control of your site's data in a GraphQL data layer. The way it looks is like this, as we have exports.source nodes, and we get two actions out of the argument. We get actions and create node ID. The create node is what we're really interested in. This will allow us to create a GraphQL node that will then be available as a GraphQL query. And using that, we're going to first go ahead and fetch our posts again. We're going to then say, okay, we want to make all of this post data available in a query called post data. So we're going to say we want to query GraphQL, post data, and then we're going to have data, and then we'll have that array of data. And to do that, we just then call create node, passing in this post node meta, which is kind of a Gatsby specific API. Just going by their documentation is how I figured this out. ID, parent, children, internal gives the name. And then every time you call create node, you're actually creating a new GraphQL node that's then available as a query. So now we can just query this inventory data anywhere we want. But we're not only creating inventory data or post data, we're doing a bunch of different things. So we might want to have, we might want to create our navigation dynamically based on our pages. So we might, put that here and then fetch that in the nav component to dynamically build our nav. We might, have other dynamic stuff, but it just allows you to do that dynamically because at build time you're fetching the data and then you can kind of have that available. And then for dynamic data, you can just use a regular GraphQL query. So if you think about this type of app away from a blog post, think about a e-commerce site. You might want to have the benefits of both Jamstack and a single page app into one because you want the SEO that comes with and the speed that comes with Jamstack, but you also might need dynamically to know how many inventory items are available in stock. And you might have 1,000 items in your store, and you might not want to rebuild your site every time someone buys an item. So what you can do is dynamically fetch just that inventory number, but build everything else. So the page loads really quickly. You fetch that number, and then you have kind of that combination. So next is storage, and this was actually pretty a big problem for me at first until I kind of figured it out because it seems like it would be simple. And when I say storage, I'm talking about image and video storage. So let's take a look at the two types, so local and public. Local is meaning I want to actually take every image that is in my app and download it and put it in a folder. Okay, so I'm taking the image from the cloud, downloading it, setting it in a folder, and then I also want public access, or this could actually be more like public or private access, because if you're sharing a post that hasn't yet been deployed yet, then it's coming dynamically at page load. If you're actually in the admin panel, you're fetching images at page load. So you need both types of access. So let's first take a look at public access, which is the easiest type of access. Basically, all you do is use the API of choice. So if you're working with Cloud Canary, you just make a request, you get that image, and you have it, and you're ready to roll. With GraphQL, with Amplify and S3, we have this storage component we call storage.get. This gives us a signed URL, and we can now render that image. So public and private access is pretty simple. The thing that really was interesting to me was the local image and video data, because we're saying at build time, we want to go fetch the images that are in our entire app. We want to download those images to a folder, but we're not just working with image URLs. We're actually working with things like Markdown, and we're working with things like HTML. So what we end up having to do is parse all of the Markdown and find out when there is an image. When we see an image, we then need to download that image, replace the reference that image in the Markdown with that local URL, and then rewrite that entire piece of Markdown. So to handle this, I first created a download image function that's kind of like a big abstraction that just does the downloading. So this is pretty straightforward as far as working with Node file system. File system.create write stream, and then you use Axios to download the image using the path that you create. But that's not the difficult part. The difficult part to me was kind of like figuring out how to parse the Markdown, how to find out where the relative URLs were, and all this other stuff. But anyway, so the idea looks something like this: is basically you create a relative URL reference to where that image is going to be downloaded. This could be whatever you want it to be, right? But for me, I was like, okay, let's go ahead and make it just a downloads folder, and we're going to put all of the images in the entire app in this big downloads folder or whatever. You could probably make this more polished by creating a more dynamic file path, but just to make it simple, putting everything in downloads doesn't really matter, right? So we create this relative URL. We then need to get a signed version of this image using our API. So if you're using Cloud Canary, you would use an API key. If you're using Amplify, you call it storage.get. And storage.get looks for your local Amplify configuration, because you don't want anyone being able to go and kind of use your storage service for free, right? You need it secure. But you also don't want to kind of leave an S3 bucket open ever. So you don't want to just have a way to just fetch that URL. So the way that you can do that is you can say, okay, in this build step, we're going to map over all of the items in this array, be it post or inventory or whatever. We're then going to call storage.get, and we're going to get a signed URL. We're going to pass that URL into that download image function. That's going to do its thing. But what we now are going to do is we're going to replace the reference to that image locally with the actual relative URL, because we're just going to we don't care about the actual location of that in our database because this is static. We're now working with the local reference. So then we set the image reference as a local URL. So now at the build step, we're going and we're looking at all of the data, all of the posts, all of everything, downloading every image locally. And this is important because when you have Jamstack, you want it to be fast. When you're actually fetching an image at runtime, you're having latency because you're going and fetching that image and it's there. But when you have it locally, it's in the folder, it's there, it might be even cached, right? So that's the storage layer. Let's take a look at now how to deploy this. And this is pretty cool the way this actually works out, because you don't actually need to do a bunch of steps. This is kind of where it is now, and I'm hoping to make this even more concise in the future. But just like you would always, git clone, change, yarn install, or npm install, you then need to set your admin emails locally. I'm going to change this into a command line command, so you can just say probably in the Jamstack configure phase, like an npm script. Anyway, so you want to set by default who the admins are. Another thing I'm probably going to add in here is maybe to be able to set one admin email, and then that admin can add other admins from within the admin dashboard. But for right now, it's all kind of hard-coded locally. Okay, so that configures everything locally. Then pushing this and deploying the entire full stack, you run jamstack init. This actually looks at the infrastructure as code and deploys a base version of the app. So it goes ahead and says, okay, this person is initializing a new CloudFormation stack based on the CloudFormation resources. And then you run jamstack push, which runs under the hood amplify push, and it deploys all the databases and the GraphQL and all that stuff. So you've deployed at this point the back end. Now to test it locally, you run jamstack develop. This actually runs a build and then runs a local port of 8,000 and kind of deploys it to your local host. And then when you're ready to deploy, or you're ready to like just run the build and do whatever with the build, you can just run jamstack build. A few other things to kind of note. I added theming. So this is a look at the admin panel. By default, it just comes with a few themes, but you can kind of switch between those. But really importantly is a webhook. If you want to deploy this thing, you probably don't want to go like log into Netlify or log into Amplify Console or wherever you're doing your hosting and like click a button. If you're an admin, you want to be able to just deploy it locally. You can actually run Jamstack configure webhook and then just paste in your URL, and that will go ahead and hook up the deploy button to your hosting provider, and then it'll run a new build. Also built-in auto image resizing, because if you upload an image that's 4,000 pixels wide, it's going to be very slow. So I have a Lambda function that has configuration for anything that's over 1,000 pixels wide to resize it to 1,000 pixels. That's about it. But you can actually go in there and kind of modify that. That might be a good thing to add into the CLI itself, so you can kind of configure that. But basically what happens is whenever you upload an image from the admin panel, a Lambda function gets triggered. In that Lambda function, we then fetch the image. We look at how big it is. If it's smaller than 1,000 pixels, we don't do anything. If it's larger, we resize it and then store it back in the database or in the S3 storage. Parsing of Markdown and HTML, I talked about that, but we don't only do that at build time, we also do that at runtime, because when you're, again, thinking about how these secure images work, you're fetching an image that gives a signed URL. So if I'm working in Markdown, how does that even work, right? So I'm like uploading an image, pasting the image URL there. If you paste the image URL as a signed URL, it's like this long or something like that. So what I ended up doing is there's a toggle between preview and save. So in preview, we parse the Markdown and strip off all of the signed stuff. And whenever you save, you toggle that back. We then parse the Markdown again and then inject the signed URL. So when you're previewing it, you actually preview the dynamic image. For the page builder, there's two types of pages. There's an actual web page builder and a post builder. For the page builder, I use Slate.js. Have a lot of work to do on the page builder. If you look at WordPress, WordPress has been around for 10, 12, 13 years. They still have issues sometimes with their page builder because it's a really complex problem to solve. I'm going to demo how this all works in just a moment, though. So anyway, for the page builder, you can create a new web page. You can add images. You can format all that stuff. I use Slate for that. And for the post, I use Markdown. So I used Marked, which is a pretty nice open source project. The scripts that I've built that come with it, and I'm thinking about putting this into an NPM package. You have Jamstack init, which first of all goes into some configuration behind the hood, under the hood, and gives you a dynamically unique S3 bucket, because when you're working with Amazon S3, the bucket has to be global unique, meaning no one in the entire universe can have the same URL. So I just go in there. I use UUID to kind of dynamically generate a unique bucket name, and then we run Amplify init under the hood. That initializes the stack. Jamstack push runs Amplify push under the hood. Create local config goes into your, this is kind of Amplify related stuff, but it basically strips out the API key because you don't want that public. Same thing with build local, and then build just runs Gatsby build. So I'm going to do a demo, and then I'll be done. I think I went over a little bit on this. So let's take a look at what this looks like. So this is kind of a deployment of Jamstack CMS. This is a a deployment that just, oh, it's not showing up, is it? Okay. Let me do mirror displays. All right, so yeah, this is just kind of a look at what Jamstack CMS looks like if you just deploy without any pages. All I have now is one hard-coded page and a few blog posts. I am signed in as an admin, so you'll see that I have the admin panel button there. These are all posts that were written in Markdown. This is kind of the look of a page, a post, I'm sorry. If you'd like to edit a post and you're signed in as an admin, you'll see this Edit Post button here. You can click Edit Post. This will now dynamically fetch everything as it currently is. You can make changes. You can paste in Markdown. You can write code, whatever you would typically do in Markdown. You can preview it here. You can also unpublish it, which will basically, next time you run a build, it doesn't show up in the build. You can generate a preview link. You can change the cover image. And then you can actually upload an image, which will allow you to upload an image, and then it'll pop up a kind of an overlay that gives you the image URL that you can paste directly into the Markdown. If you go into the admin panel, you'll see that you have a couple of different views. You have a view of all of the posts that you've created, and you have the ability to publish and unpublish posts. So you notice that I unpublished this post earlier, so now it's not published. It allows us to publish it. We can create a new post. The only requirements are that you give it a title and a description. You can also add a cover image, all this other stuff. You can view all of the current media that's currently in your app. And you can also toggle between images that are in use and images that are not in use, because you might want to view and delete images that you're currently not working with. You can view all of the web pages that you've created, and you can create a new web page. So I'll go ahead and create a new one called Paris. It'll automatically create a slug for you. Even if you kind of have uppercase stuff, it'll automatically lowercase it. And if you put a space, it'll automatically turn it into a slug for you. So let's say we want to enter an image. We'll go ahead and set that image. Make sure I have something appropriate. Okay, so we set an image. We might want to also add some rich text, and then we might want to add like a header, and then maybe a subheading, and then some more rich text. Cool. So I've been playing around a lot with this code, so I hope I didn't break anything. So we should be able to go ahead and either save it or publish it. All right, so we should now be able to go to View Pages and see we have our page here and be able to kind of view and all that stuff. Back to the admin panel, we can also look at the settings. Oh yeah, by the way, there's like going to be different types of pages, but for now there's only hero. This is the admin panel. You can set the site description. You can toggle the border, or you can maybe make the border larger. You can set different themes like dank, dark, and reactive. I think dark is pretty cool. And then when you're ready to deploy, you can just click deploy. And I think that deploy button isn't connected to an actual webhook right now because I'm in production. I have it configured to where if I'm developing, I don't actually have the right webhook to be open source. I don't want people to keep rebuilding my app. But anyway, but that's kind of it, yeah. I'm going to go ahead and we'll be done with this. So that's the demo. Similar projects that I'm working on. Conference App in a Box is a full stack serverless conference app that I released last year in July, or maybe August. Over 100 conferences are using this now. I've had 5 or 6 consultants that I've worked with, and they've actually deployed and sold this app, average $10,000 to $15,000 per person, per client, and it only took them average 5 to 10 hours to actually build. This is React Native and Expo. It actually runs React Native iOS, React Native Android, and Expo, and it also runs on the web with React Native Web. But it's the basic idea, themable, full stack. Jamstack e-commerce, similar to Jamstack CMS in the same repo, except it's backend agnostic. It has nothing to do with AWS. If you'd like to learn more, check out github.com/jamstackcms. looks like that. And that's it. Thank you. And follow me on Twitter at Dabit3.
Does anyone have any question? I will give you the microphone so that we can hear on the stream.
Hi. Do you plan to include extensions like WordPress? Because the strength of WordPress is mainly
right in the plugin system. Yeah, absolutely. That's something that I've thought about, and I have a couple of prototypes around how that would work, but I haven't actually integrated anything yet. I think this was released at the end of 2019. I haven't had a lot of time to work on it. I just released a separate project, but I think over the next couple of months, I'm going to be polishing up some ideas. And I kind of published this under version 0.1, and my plan is to release version 1.0 within, at the earliest, 1 year. So I have kind of a long roadmap to kind of add things like that. But if you'd like to submit any ideas around how that would look, I would welcome an issue, a GitHub issue.
Or a pull request.
Yeah, or a pull request.
Any other question? Don't be shy. Oh.
Hi, thanks for the talk. I used to build a website with Gatsby. So as I understand, you are using the GraphQL server of Gatsby with another GraphQL server from Amplify, right?
Yeah, so I'm using the Amplify GraphQL server as kind of a main API layer for external data to be able to be kind of modified. And then I have the local Gatsby GraphQL data being made available by that GraphQL request, I guess you could say.
So I guess you have some files with two different GraphQL requests. One from Gatsby.
So the yeah, I guess you could say that.
Isn't this weird?
Well, Gatsby doesn't. Does Gatsby have an actual GraphQL API like as a service?
Yeah, I mean when you are developing locally, you have your.
Oh yeah. When you're developing locally. Okay, so there's two GraphQL layers available after the app has been built. One is querying data that has been requested from an actual like real data source, and then I have a few things that are made available that I guess are kind of a modification of that data, things like the navigation and things like that. But as far as actual sourcing the GraphQL data itself from a data source, yeah, you could probably use, I mean, you could definitely use any GraphQL API, but I don't think Gatsby has what I needed, I guess you could say, for this project.
Okay, thank you.
Yeah. Question? Yeah.
Yep.
One more. Oh, I'm sorry.
Hello. You say you use Lambda for resize images, but Gatsby let us resize image and put the better image from. If you know what I mean. There is a plugin on Gatsby who do that.
Yeah, that's a good point. I'll probably look into that. The only downside I think I could see from that would be if you had a massive site and you were still requesting those large images at build time. I don't know if that would be a concern because once you resize it once, it stays that size in your back end. Whereas at build time, you would kind of need to redo that over and over. But that's something I'll investigate. That's actually a really good idea. Do you know the name of the plugin for that, or just how that works?
Gatsby Image
Gatsby
Sharp.
Image Sharp. Okay.
Actually, we use
I've
it
used
for
Gatsby Image Sharp before.
Yeah, we use it for the regular website, and when you build it, it downloads the files again, but it doesn't resize them. It caches them, so you don't need to resize them every time you rebuild the site.
Okay, got it.
But
okay,
you do
nice.
need to re-download them every single time, so that's.
Okay, nice.
Any other question? Or otherwise, we can chat after. Oh, you want to? Last one?
Sure.
I've seen that you handpicked the fields when creating a page. Do you persist the schema? Can you have like custom schemas?
The schema is available like locally if I wanted to request it, but as far as persisting it, do you mean in which manner? Oh, okay, yeah, like custom. Okay, got you. No, that's something that I've thought about doing, and I've thought about how to actually make that work, and I haven't figured it out yet, honestly. Sure. Thank you for the question.
Okay, thanks, Nader. That was awesome. Okay. Nader will be giving a workshop also at Rec Europe if you're interested on May 12th.
Yeah, we have here May 12th.
On Amplify. Okay, we'll start with the second talk in French, I think.